and vision for 2 decades, and focusing on enhancing communication to media. She founded Digimon to create high-fidelity digital humans, transforming user engagement in digital environments. With a PhD in computer graphics, she is a professor at the Porto University and a TEDx ambassador. Veronica has contributed extensively to the SIGGRAPH and has collaborated with Microsoft and Universal Studios. An EU EIC mentor and ambassador since 2024, she was named as the UI Winning Woman in 2022 and shortlisted for the European Women Innovator Award in 2021. She builds a career with a strong commitment to education, digital expression, and motherhood. And her talk is titled Workflow Automation, the Invisible Thread Behind Creating Digital Choices.
Thank you so much for the very kind invitation. Before I introduce myself, and thank you for the introduction, I'm just going to show you something to inspire your imagination. Should I just click here?
In the beginning, there was a whisper. An echo traveled through our worlds. It asked, can a universe exist where every dream intertwines with the threads of countless others? Do you hear it too? A place where we can forge our reality. Where we can be anyone. Go anywhere. Do anything. A place where we can rise as heroes or reign as storytellers. Where dreams are crafted and boundaries are blurred. A universe as limitless as our imaginations.
So what you just saw on screen, just on the character slides, it took me and my team about 2 decades to finally automate the full character creation process and beyond. So I'm going to do my best in these 30 minutes, 45 minutes to unpack how we've done it. I won't be able to get in all the technical details that maybe a lot of you might want to know, like algorithms we used and everything, but I'm more than delighted to then at the end answer any questions. My whole goal is to give you an overview of every element that was needed in order to, take 2 decades to actually automate what you saw on screen. So my name is Veronica, and thank you for the introduction. How do I move this on? Are we good? Oh, I found it there. The topic of this presentation is how we automate workflows, in particular that in what I call the invisible thread, on how we create all these characters and what every character needs in order to come to life. And not just come to life as a plain 3D asset, but more as an element of interaction that eventually someone will put a behavior in it. And it could become your identity in a game, it could become simply your 3D player, it could just literally be whoever you want. So a little bit about myself, I have 3 hats. I'm still a professor at Porto University where I teach computer graphics. And I love teaching computer graphics, so hopefully I will be able to manage to stay there for a long time. I had a research lab for more than 10 years at Porto as well, until we spin off and we created Digimon, which is this, Porto University, but the core algorithms actually come from my PhD that I started, I did almost 2 decades ago. And then the third hat, which for me honestly is the most important one, so hopefully no one take it wrong, is what I do on my spare time and where I try to to instill in everyone that I work with, which is the passion for sharing knowledge and helping others to have access to education. So I do quite a lot of initiatives in order to sponsor kids. For instance, in Tanzania, there are these big Swahili and our orphanages, and so we fund English classes so they can have a brighter future, or fund kids that come out from high school to go to university, like Porto University, and then do internships at companies, and many more. So for instance, these girls are girls from South Africa that they will have no ways of going to college except for the fact that every Saturday they get special classes from EY, and when I go to visit them, I manage to stay with them and explain them and do online classes on IT so we can help them prepare better their college applications so they can get scholarships and many more. So pretty much thanks to the fact that I was fortunate to have a proper education, and I've been teaching for more than 25 years and then created you, and I'm able to do what really is my passion, which is education. But you're not here to listen about that, so I'm just going to continue just with the tech. Okay. So just in a snapshot, this is my history, I would say, in one slide. I think it's the combination about what we learn at school. I started working at IBM when I was 18, before actually going to college. So that's what I call the enduring bit, everything that you learn at your workplace that complements what you get from the university. I finished my engineering degree in the US, then I came back, huge economic crisis in Argentina, and came to Europe. That's how I ended up in Europe, and did my master's degrees on video game design and then my PhD in computer graphics, where I work very closely with a lot of game studios and film studios like EA, DreamWorks, Pixar. So I spent about a year and a half just researching which problems were really, really hard to solve. Within that, you have like physics simulations or 3D building reconstruction, or environments, or tree generation, and within that it was facial animation and 3D character creation, and I just got passionate about it. And no one knew why it was such a bottleneck and so difficult to solve, so I said, okay, I'm just gonna build a whole system and I'm just gonna automate the whole character creation process. I failed miserably in that in my PhD. I only solved one tiny bit of the puzzle, which was retargeting. So I created an algorithm, which is was an RDF function where you could transfer data from one model to another model. And it was the first algorithm that allowed to do that. We're talking about almost 2 decades ago. So that was my PhD. But I think life is above and beyond what we learn at the school, what we learn at our workplace, but it's about the opportunity of what the world brings to you. So I'm very fortunate that I've worked with all these companies and involved in all these organizations, and got the work published in many places. But I think the most important bit that made who I am is all these opportunities of traveling all over the world, living in very weird exchange places. Like I lived at an American Indian reservation, and I managed to stay with gorillas for a couple of days, and really live and breathe the life in Rwanda after they suffered genocide. So I think all these things kind of like make us who we are, and it gives kind of a purpose in life, and makes you think out of the box when trying to actually solve difficult problems. So I believe everyone here is trying to solve very difficult problems, and it's not a linear way to do so. So for me, all this traveling, all the challenges that I went through, kind of like trying to make you think completely out of the box. And that's how we managed to finally automate the character creation process. So this code started, as I mentioned, in 2004, roughly. And it had two purposes. One is, okay, how can we automate the 3D character creation, and how can we build up a pipeline that could scale productions? It's really, really expensive to do so. So how can we scale it, right? And eventually, how can we do it at a lower cost? As we could see, for instance, Baldur's Gate was like a fortune, the Baldur's Gate 2 was a fortune to actually develop. Probably not many game studios will ever be able to do something like that again. So how can we create technology that can decrease those costs, but most importantly, will not kill the creativity in the artists. Okay? So it takes us to point number 2, how can we actually empower the creators so they can actually create, in this case, game assets that are ready to be ingested in a real-time system. So what I did about my PhD was what I discovered really was there's no artist, no technical director that will give up their creativity, that will not give up the way they create the rig, they will not give up the way they set up the textures, they will not give up the way they paint the textures or how they create the 3D mesh. They will not. And in fairness, they should never. Right? Because they are the ones that actually know how the morphology of the character should be, how the behavior of that character should be. There's no way that can be given up. So my purpose was, okay, how can we create tools and systems that will empower and maintain the specifications and the art direction the art is given, and we create a software that is generic enough, or algorithms that are generic enough to transfer all that data to automate the more tedious tasks. So that's when Didimo comes in. For 10 years we had the research lab, and on and off 20 students every year out of European research projects, ICT projects, a lot of research went into it, many publications, many major conferences that you all might know. But then it gets to a point that if you want to actually build something that someone is going to use, you need to make a product out of it. So 10 years of master's degrees, PhD, 10 years at a research lab, and then 6 more years to actually productize what I'm going to show you now. Okay, we'll just at the beginning of the presentation. So there's like a big kind of like gap or transition between all the algorithms everyone develops into actually building a product and a pipeline that can be actually used at a working environment or at a production. So that being said, and I'm oversimplifying the process, if we look at a 3D creation pipeline for characters, you have those stages, right? Modeling, texturing, rigging, animation, and shading. And it's a very, very sequential process. So that very sequential process needs to suddenly work seamlessly, and you need to be able to go from one stage to the other, back and forth, and allow iteration to the artists to fix what is going wrong. For example, if I am creating, this is a real example, many years ago, actually when I was finishing my PhD, EA needed to create, they created all the characters for a basketball game. When they were very close to ending the production, the art director suggested, kindly, suggested, it was more like, I want more triangles, by the nose, on the eyes, and back of the head. We were talking about roughly 100 triangles that were added on that mesh. The big problem is that all those 3D characters have already had their UV map and all the texture done, right? So the question becomes, what do we do now? We need to do all the UV mapping again. We have to reassign where the UVs go on this change of geometry. So that means the hundreds of characters that have been created needed to go back into the modeling stage, then into the texturing to redo the mapping, and then go back into the rigging to adjust the rig and see if there was any change because new geometry has been added. All the animations needed to be checked and redone because probably they're not going to be moving very well to the size of the eyes, and therefore the shading, by the time it gets to shading, it should be okay. So all this just takes months of work. That's just one tiny example, and I have many of those. So the whole purpose was, okay, how can we continue building small tools that, okay, change the geometry, let's just propagate all the UV mapping, let's just propagate all the new, do the retargeting of all the animations, right? Let's just redo and launch and drop into the game engine or in Maya, whatever we want in order to do the final animation. So that's the whole purpose, is how can we automate this whole sequential process. So that's what we've done. It's kind of like a very magic box that you go from one character. So the way it works is you put the base template. So an artist will create the base geometry, will create all the base textures, will also create all the garments that they want that character to have, right? And then you can start creating variations and start creating different types of characters. Thinner, taller, stronger, fatter face, smaller face, however you want. And then create all the crowds. So, automatically. So suddenly you can have a football stadium where you created maybe 1, 2, or 3 base characters, all the outfits that you want, and then by just clicking a button, it will just generate all the characters. So let's unpack that. So the main needs that we get requested from, and just by being able to simplify in this slide 4 use cases, it took us like a year. Okay? Now that I see it here, it's like, oh wow, makes total sense. But before, we were only talking about features that we could do with the technology. But really, when we talk to game studios or film studios, what is even more important is understanding the use cases. What are their needs, right? So what I feel when I was doing my PhD, and I think I did it the right way, was going and asking, what do you need? What is it difficult for you to do? How are you going to be using technology? What will speed up your process? So all those questions are fundamental. And so the answer now, once we automated the core pipeline, is like these 4 main use cases. The first one is how can we create NPCs, like non-playing characters, really fast. Right? So how can we populate a city? How can we populate a stadium? How can we create crowds? And crowds is not just creating 10,000 characters, right? We can now go above and beyond, because as they can click of a button and get 10,000 characters, now the next question, it unlocks something that before was impossible, which is, okay, I want to populate New York. But I want to populate New York with the information of the density of population from New York. How many are Southeast Asian? How many are Caucasian? How many are from South America? So suddenly we can start prompting the system, and because we have all the information on how to create diverse digital humans in this case, you can start creating populations based on the imagination of the creator of that system. The same goes for a stadium. And it can even go above and beyond. Like we have one customer that they like a game studio that they want just to do an arena for a specific sport. And it's an online arena, right? But what they want to do is if you go to a specific country, like let's say Japan, you want people to feel that they are in Japan. If you go to Argentina, you want the audience and the people in the States to feel like they are in Argentina, right? So now the technology can allow you and unlocks all these possibilities. That's just for NPCs and crowds. Then the next thing is the asset fitting, right? How can we just create all the garments and automatically adapt it to the different bodies? The next one is how can we create a character details. But for those of you that are playing games, when you play a video game, you have 2 moments. The moment that is in design mode, which is the artists are creating the characters and how can you manipulate. And then you have the moment where you are inside the game and you want to create your avatar or your own character. So that requires a similar technology, but one needs to run at runtime, right? So that's the other use case that would be nice can we do. And then the third one is how can we go from a 2D concept art or a selfie to a 3D model. What goes underlying is, okay, developing technology to go from 2D to 3D, and now it's going from concept art. So a lot of the requests come from, okay, how can we go from a concept art to a 3D model? And why that is important is because the concept art has a style the games can have. So we can understand the style and then build the geometry based on that style. The second one is how can we do these unlimited variations and guarantee that every single character is unique, right? There's no repetitive characters. Then the other one is how can we do all the asset fitting, with all the layering of the garments. So it's not just one garment on top of the body, you have layers. So how can you guarantee that then the mesh of the body is not penetrating the jacket, right? And what happens if you're changing the body and you're having the same garments? Therefore, you could also do is a verification system. So once you start automating every piece of the pipeline, the next thing that happens is that you have enough data that you can start validating all the information. So then you can create a report and say the 10,000 characters actually are perfect, or character 120, 2005 has penetration between the mesh and the outer layer in vertices 100 to 100 of each other. So certainly you're giving a very powerful tool which allows to analyze and understand how the characters are being created. And then lastly, very important, the whole point is that there is no friction on when you're integrating into a workflow. So if anyone of you is developing tools or software or algorithms, it's really important to think how there is no friction of integrating that technology into the workflow of whoever you're working with, which is something that when I was doing my PhD, I wasn't very aware of it. It was so important. I did knew that when I did my first algorithms, I went from, okay, I'm not going to present it in MATLAB, and I extended all my research, and I took so many hours just to learn how to program inside Maya. So my algorithm, which was 5 lines of code, I ended up implementing thousands of lines of code because I had to integrate it inside Maya, program it inside Maya. So by the time I would go to the studios, they would actually test my algorithms. Otherwise, if I would have gone with just the MATLAB, nothing would have happened. So let's see.
Infinite characters.
So this is inside footage of City Skyline. So that was the first game we used our technology, and what you can see is the tool and the software running in live, really. So what they did is they put just one base character, and then they had all the library of garments, and then automatically they could create and populate all the scenes. So in one day, in just like a few minutes, they got done over 2,600 characters. Increasing their productivity tremendously. This is a snapshot of the first video that I showed. In this case, they gave us a 2D concept art of the characters, and then based on those 2D concept arts, we automatically created all the characters. They gave us one animation and we retargeted, and not only that, because we know every single point that is on the face and on the body, we can then put hats, assets, we can just pretty much put anything that we want. So when you're developing, it's all about understanding what the user wants to do, right? So in this case, if we look at on the right, the first key things are the limited variations. The other key thing is that they wanted to create very high quality crowds. The next one is the automatic asset fitting for all those garments. Now the fourth one is a very interesting one, which is artist controlled iteration. So that's what usually, people don't pay attention, but it's one of the things that, in this case, the audience or the user of our technology wants the most. Is, okay, I get the characters, I get the asset, but what if I want to change something? Like I said, add more triangles, how can I do that? So we need to create a bunch of other tools that would allow you to automatically do changes, and then after those changes, propagate all the same library of assets that you had. The Q&A, that is humongous. So we've never even thought about automating, the valid verification system until someone came and said, hey, Veronica, is there a way that you can tell me where the penetrations are happening, or the character doesn't look exactly how we ask? And we're like, oh, well, we actually have all the data, and we have our data set, so we could actually start predicting everything. Even better, we could actually even create reports that says, this character, which is unique, has all this bone structure, has all these assets, like jackets, hats, hairs, whatever, and we can just create lists of things, and then we can give reports, and then the artist can analyze, and just by changing the configuration of what they want, they can just create new assets and new crowds in no time. Right? Before that would have been like weeks and nightmare of asset management, just nuts. And then by default, it has to work in any engine, right? And that's a tricky one because every engine has its own specifications, so we have to build bridges for Unity, for Unreal, for Blender, for Maya, for custom engine of a specific game. So usually that requires dedicated development, and you of course cannot reuse 100% everything. I'm not going to get into this detail, but So, what is important about this slide is actually just to see how the same software can support any art style. So, same effort, we receive an anime style, we receive a more stylized human characters, and then we receive low-poly characters from colossal order, and support is the same. You just input the data. We can automatically understand the heuristics and the assumptions of each one of those characters. Understanding the character is divided in, it has one unique geometry for the whole body. Or we get characters that can have, I don't know, 20 different breakpoints on the geometry. So automating all these understanding of the hierarchies, it just makes it fine. Gosh, I have so many slides that I'm going to just look for the videos. So the way the software that works for the tool is we created algorithms for importing and verifying that the data that is coming into the system is correct. Because what happens very often is that the artists upload information and they expect the system to tell, oh, this is wrong, this is wrong, this is wrong. So it makes their work easier, and then they go and fix it. So we had to implement a system that will verify constantly if the work they have done is actually correct or not. Then you have the tool where you can create all the variations and edit if you wish. Then you can visualize it, modify it, and then you can export into the dedicated engine. Oops. So if we look in detail, if you would talk to a game studio, this is what they will want to see. They want to know that you understand what are they doing internally, right? So on the left you have everything that is in the pre-production, and then on the right is everything that works on the actual pipeline they're building. So you have for modeling, and you will have sculpting, retopology, UVs, definition, LODs. Every time you create a character, usually the character is created in very high resolution, and so then creating the LOD, which is a lower resolution of the characters, it takes a lot of time. The texturing, how do you paint on the textures? Do you bake the textures into the geometry? Or how do you create a shading system? And all this can have multiple layers, so you can have many texture maps. And then in terms of the rigging, every studio will have also their own rigging system. So is it boneless, is it boneless plus blend shapes? And they will have different setups, right? Each studio will have a different architecture on the way. And then finally on the animation side, you can have manual animation, procedural generation, physically based. So how do you understand all the mockup systems that you have, right? So we need to also know how those animations are done. So what we work for all these years is pretty much grabbing each one of these problems and automating. Okay? As you can see, still the animation is a bit tricky. We can do really good animation retargeting, except on the moments that if I need to grab, let's say this like this, or like a motorbike, and your fingers are very, kind of like really tight. So there's some animation retargeting where occlusions happen that can be a little bit tricky and might need some cleaning. But other than that, everything is automated. So if we encapsulate, and here is where I would like to spark your imagination. So far, okay, we've automated character creation, but that's not the end of the world, right? When you solve one problem, 10 more, 100 more appear. So we've solved the automation, we've solved the verification system, we've built an SDK to do in-game editing. Now the next big thing is user-generated content. So I'm a strong believer of these creators, building like a creator's economy, where the user, gamer, whoever is going to be creating their own content. So how can we then, if someone grabs, let's say, Roblox, and they create a character, or Cities Skylines, they create a character on their computer, and they want to upload it into the game. Most probably, they will not know the specifications. They will create it in a very crappy way because they're not professionals, most probably, they're not reminding anyone. So how can we build a system that can understand the unknowns of how a user that you don't know that's going to create a new piece of content like a garment, a hat, upload it into, let's say, GTA or Fortnite or Roblox. How can that happen? Okay? So it's an open question. We're definitely working on it, but it's an open question for everyone, which hopefully you can think of ideas. So let's go one by one now. In terms of I've always, since I was doing my PhD, I've always wanted to be really in the detail of how can I make things for the users cheaper and faster. Because at our lab, we could not have, for instance, a lightning stage, right? The amazing one that Paul Deverbeck built, right? So we need to always do things cheap and fast that work well. So that's one of the main concerns. The second one is how can you make productivity faster, right? And then the third one is how can you optimize production. So in terms of the optimization of production, it all has to do with the rendering. So if we're creating 10,000 characters or 2,000 characters, you cannot put those on screen at the same time. So you've got to build also algorithms that instead of doing 1,000 draw calls for 1,000 access, you just do a couple. So these are the three key things when you're developing new technology we're always looking into, right? It's reducing cost, increasing productivity, and then optimizing processes. So I'm just going to show you, because it's better said by someone else than by myself. So, whoa, what is it?
So that's when video came along.
Hi, my name is Damien. I work at CTO at Barcelona. What did Populate mean for me from a technical point of view? The power of generating a large amount of variations for the characters in the game without spending a tremendous amount of time working on those characters. We were able to create. I do not know if it's an infinite amount of characters, but a very large amount of unique variations by just using the same basis for all our characters. Populate did save me and the team a lot of time. I mean, working very much out of the box, we had very little amount of work on our end once we had the original asset imported into the Populate tool.
Hi, my name is Hans Zedinger. I'm a creative director at Closewell Border, working for our next game city Discussions tool. If I would mention one key feature from Populate that helped the most, it is difficult because there were so many. But if I pick one, it was the ease of use that I could make like hundreds of thousands of characters real time, just using the sliders. Very easy. So I think the bulk creation of different variations was the most important. So the art style we defined, the Populate could use that. And whether it was a different ethnicity or thin or tall, it still was our art style.
When we met, we were at
Okay, so let's go back. I'm going to jump now to a few use cases to show you results, so it gives us time for you if you have any question that you want me to technically deep dive on, okay?
Just a small technical detail, I'm sorry.
base mesh, okay, and a base textures, and all the base assets that they want to use. So we do not generate that base initial asset for a couple of reasons, and I think this is very important to share, so you understand the logic. First one is IP, and IP ownership, okay? So we don't use generative AI. All the backend is done with machine learning, computer graphics, algorithms, computer vision algorithms. We have our own data sets. So we didn't want to, from an architectural point of view, we didn't want to generate assets because we didn't have enough of a data set, right? Enough of a big database that can cover all potential art styles that everyone will want. So that was the smart decision on how we did it. You give us the first one. Of course, it has a limitation in the sense that if you're a small studio, then you don't have even money to actually build that base character. So the next thing that we're going to be doing is partnering with companies that generate that initial asset. So we will never have the problem of the IP or where the first generation is created. We're an automation tool. Okay? So, let's get back. So, one of the things that you should be able to do is that you see on the right, you have all the characters that you generated, and you can start grouping them. You can start grouping them and creating new variations of them, and then you can export them automatically. The hardest buttons to automate this whole software was the import, the export button. So at the moment we work with big studios because we do an initial onboarding of those initial assets, the base mesh, the base textures, we do it. It takes us probably a couple of hours, and then we give the software directly into the customer. And we're still working, hopefully we will have the import and the export button by GDC next year, which is March, and then we can start scaling the software. But this is just to give you the dimension of the complexity of what it is. You can upload anything you want and then do magic, right? Not crazy. So in this case, what you can see on screen is when you're manipulating the assets, you're actually accessing a data set, a database that we have at the end that can do an initial variation of the characters. So what is really cool is every time the artist can do a new variation, like as you can see here, he can save it as a new shape. That new shape goes back into the database, and our database starts growing and growing. And each database that we have belongs to each game studio. So we're just kind of like gradually creating good content because the initial content is created by the artist. And I'm going to show you, in a given time, I'm just going to show you this, which is the whole process. So you have on the left how you can start manipulating and creating more DNAs or more base templates. On the right, you have all the different garments that you want to use and how you can customize them. And then on the far right, you can actually create a button that you probably don't see very much, but it's like right here. And you say randomize, create 100. And based on the definitions and the manipulations you've done, you created all the characters. And then they are ingested or exported into the game directly, which is another thing. Each game might want the data to be exported in a specific way. So for instance, for City Skyline, they didn't want to put the garments with color because colorization was being done in their engine. So we customize the specifications that goes on the output file to the needs of the game studio. And that's what we're trying, hopefully by March we will have the last bit of the automation. And I want to show you one more thing, two more things actually. So in this case, well, those of you that are familiar with 3D is about LODs. So when the camera is too far out, you want to have characters that are less expensive, and when the camera is too close, you want to show the higher resolution. So on the fly, we created all the variations, all the LODs that then they were ingested in the engine, and then through game programming, the game engineer will decide how to trigger those LODs. But all the pre-production of creating all those LODs were done automatically. Okay, so this is a really tricky one. So what you see on screen is how you can actually change from a human to a goblin the same asset, completely different body proportions, and the characters still work satisfactory. There are some limitations, but I don't have a video here because we have it under NDA. But the hardest problem is if it says, I don't know, Roxy, Adidas, Puma, if you have like specific texts written on your pattern, how do you maintain the proportions? And then the other thing for the asset fitting that you need to think about is what is a rigid and what is deformable. Right? So we are able to allow the artist to decide, okay, if you're having this very sophisticated armor, which bit you're going to allow to deform, or which bit needs to be rigid so it still remains an armor. Okay? So, in this case, you can actually see the layering and how you change all the bodies. These are all this is one of the groups of city skyline. Then you can have the firefighters, you can have pedestrians, and how you can see the body being changed, hopefully. Can you see correctly? Yeah. So how you're literally adapting, and the garments adapt accordingly with no problems. Okay. So we talked about how you change skin colors, faces, bodies, now the asset fitting, and now one of the two last things I think are more are very interesting. Okay. So in this case, is how you can actually, this is running in real time inside the Unreal Engine. So you have on the top the eight basic DNAs of the base meshes the game studio created. And then what you can actually start doing is start manipulating each bit of the character. Okay. Oh, yeah. So you can actually start seeing how you can manipulate different parts of the face. Now it's touching the nose, and you can do all these changes and save that as a new shape so it becomes available for all the new variations that you want. So this was one of the very first prototypes, and the reason I'm showing it is because I want to show you the end result of what happened. Once you've done all the modifications, then you can actually start creating automatically all the new variations of the characters. Really quickly. So this was our first prototype, but was really interesting what we managed to do next, which is yeah. So what you can actually start doing, this is inside the standalone, we are almost in real time, and you can start again, same concept. What you will see is the parameters here, because each game studio has their own way of manipulating the face, and you can do it on the body as well. Okay? You can start in real time, do the changes, it comes in your blend shape, and then at the end, you will be able to create, again, unlimited characters. That now, it takes you to the point where you can apply to same logic. Onboard the new assets, modify whatever you want, create a new shape because you're being saving them all the time. And it follows, we know it is correct because it was the artist that created the rig in order to create these modifications. And so after they've done that, you can actually create all new creatures. This is a game that's going to have like 8 different species. And now we're talking that it's not just characters anymore. We can even do creatures. Okay? Same logic. So we start manipulating the characters. You do all the changes you want. You create the shapes. They are uploaded into the new data set. And then that data set becomes available. And then once you click on randomize or create 100 rubber parts, then all of them are created. So suddenly you went from thousands and thousands of hours into a one-click button, always controlled by the artist. But it gets even better. We got a game that now they say, oh, Veronica, but can we just do hybrid characters? And we said, yeah, sure, we have the data. So now what you can do in real time, you can upload one of your DNAs, which is a human, and you can upload, in this case, a goblin, and you can in real time start creating hybrid families. I'll show the last one and I'll quit. Okay? So you can actually start creating, hybrid characters that have never been before. So this is running in real time in the Unreal Engine. This is what the games are going to be able to see when they create their mutants, right? So you can have one base character that's a human, 3 different Dragonborns. You can have, I don't know, Hellblade, Dragonborn, and human, and start creating automatically those new species. So I think because we're running out of time, I'll have to stop here. And maybe on another occasion, I'll talk about the humans. Yeah. Well, thank you so much. And,
thank you, Veronica. Very nice argument. I have some questions, but let's see if from the audience there are before.
I'll keep on putting videos just to inspire you. That's so many.
Some other questions from the audience? Oh, I have. How do you control the plausibility of the result when you generate dozens of characters that maybe people will have to check everyone if for example, I imagine with complex meshes that could be compenetrated when you randomly change. It's not maybe random, but you generate many variations. Is there something
That's a great question. Is the section 4 that I didn't explain? Yes, but the short answer is that because we make the decision that the artist is the one that defines the constraints, then we know that every output will correspond to the quality that's been defined in the input. That was the smartest decision we did. That was like, and that comes from my PhD. When I did my PhD, and they said, what is your biggest contribution? It wasn't actually creating an RBA function that can transfer data from one place to the other. No, it was actually discovering that if I let the artist define the constraints, because they do it anyways, right? They create the best mesh, the textures and everything, the rig, they put all the constraints in that original character. So that original character is given to us. Of course, we have to transform that into our own internal definitions. We do all the changes, we do all the variations, and then we output back, we convert back into the file format and the specification the customer wants. So we don't even need to worry about the constraints, because the constraints are given by them. And because we have the fact that the editor, that's why I wanted to show the editor, because that was another really good thing that we created, was the artist defining how they want other potential variations, because they've already created the rig themselves, so they know how far they can do it. And then it's just a really simple decision, right? It's just that they feedback the data set instead of, because we didn't, it goes back to the logic of we have no money to create hundreds and thousands of 3D data sets. So let's just ask the customer to do it. And that's how we did it.
So the base avatar has to be created using a tool of your toolchain.
So the base character, the base asset is created by the customer, with whichever tool they want.
So they can import in the system.
Yeah, so that's
then in the system they define the constraints, I suppose.
No, they already give the constraints come already with that base character. When you're creating the rig, you're also defining how much the mesh can be deformed. So the artist defines exactly how they want it. Well, all we have to do is understand it. That's why the input button and the export button, they're the hardest button of the whole software because we don't know everything that will come in, and we need to learn it, translate it into some of our own algorithms to be able to then output again in the specification that was given. We do have, like I didn't, was a bit, I was being a bit serious, but slide number, section number 4. So we have a data set of about 120 3D humans that represent the different ethnicities, right? So we can either grab a concept art or a 2D photo and convert it. Okay, that's machine learning, computer vision, computer graphic mixture of algorithms. We understand all the data points and we deform up to like 98% accuracy. And then, because we have those only with 125 elements, we can create the reconstruction. But when we want to create a unique ones, right? These are completely synthetic. They don't belong to anyone. So it's fed by the variations we can create based on those 125. Hopefully I said that. And then you can see, I mean, we can do within different ethnicities, many different ones.
Let's see if someone has questions. Okay.
Okay, so first of all, thank you for your amazing talk and congratulations for your amazing work. Some of my students are working exactly on using animation and using Unity and Unreal for animating characters. And so my first question was, do you have a suggestion for them how to start if they want to use your software? And the second question is, how well, because one of the problems that I see with animation typically is we always use motion capture, but then we have to adapt to different, for instance in your case, you adapt the size of the characters and so on, and sometimes adapting the motion is not
the emotion or the motion?
The motion.
The motion.
How well does the motion adapt? Because sometimes I have the impression that in most games that I see the motion is not really human. It's like sometimes we have the impression that the characters are floating. And that's okay. Thank you.
So I play videos because videos are more fun. But the animation, as I was saying when I mentioned the case of the retargeting of animation, is definitely within our pipeline the hardest one. Maybe it's because it's almost the last one on the sequential process that I showed we're working on. So we can do retargeting of animations even if you change your body height and the weight. The weight is easier than the height. But we can solve that problem. We can even solve if you're putting high heels, you know, and how do you change from high heels and then suddenly the character you generated has tennis shoes. And it's still a walking cycle, right? So all these are special cases that we detect and we automate. It's kind of like an exception to the system, right? So we're working along building all these exceptions to the systems like the one I have just described. It's a walking cycle, the one has high heels and the one has tennis shoes. The whole dynamic of the walking changes completely. So we haven't completely solved animation. We have, if you're playing basketball, if the high heels tennis shoes, yes, because it was a must, like everyone was asking for that one. Grabbing like a motorbike, we did fix it because we were asked. So we're working one case by case. So if you can come up with one of your students and we solve animation for everything, I think it will be amazing. Because it's really, really hard, the retargeting of animation. We then do procedural animation, but we rely on the customer data. So probably my answer sounds very repetitive, but the smartest thing we did is just let's have the artists create. That's what they're good at. They create it, we understand it, we translate it. And that was the bear. So we can do bear, chickens, we can do now above and beyond characters. The same technology works also for instance, if you want about the bear, you saw it. I think this is, now the next thing that we were asked is, can you just do props? So because we can do variations of body faces that are so difficult, variations on garments, now the next thing is, can you just create different props and create an editor? And again, the logic is the same. We ask the artist to create the different pieces of, in this case, of the sword, and then we can create infinite variations. So now we can start scaling and repeat the same method we did for other areas, which is magical when that happens, right? Because you build a very robust system.
Okay, other questions?
Thank you very much for the presentation. Very interesting talk. I'm just wondering, because you mentioned these are like different components and you can put them together. I'm just wondering how soon it will be, maybe like it can be like prompt based, like journey. So I'm just interested.
Excellent
how
question.
soon that will be, and what's your vision about that?
That's an excellent question. It's on our roadmap. If you ask me, I like things being done very fast, so I wish it was already implemented. So yeah, so I see that as the way we have thinking on the architecture is a different layer. So the software at the moment, other good decisions that I think we've done is the software is a standalone application, so you download it. Okay, so that means there are no cloud API costs, right? It makes it more of a difficult business model, but I'm a researcher at the end of the day and I want to make things as efficient as possible. So you download the software. First, really good decision. So answering your question, the prompting will be a layer on top of that standalone application, and that layer will be web-based. Why? Because the idea is that we will partner with different companies that generate assets, components, so then those components can be fed into our tool, and then you can create a combination, as you saw the swords, you can ingest the data that was generated by prompting. Yeah, so that's how it will work. But it's an excellent question, and I wish it was already implemented.
How soon do you think? Years?
No,
Yes.
I want it sooner.
Okay.
But you're talking to me, now if you talk to the CTO and the engineers, they kill me every time I say. So the roadmap that we have is, the first thing is now because we don't have the import and the export button, we're working on it. We can only work with big game studios, right? Like the other ones, these are all people coming out from EverQuest, from Sony, right? So we can work with them because we need a day to ingest the data. As soon as in March, and I'm saying March, and that's our deadline, and our deliverable, we put the software, we will have a waiting list, and we will have a small group of companies or even individuals who want to use the tool, we will be able to download it. That's for March. And they can use it standalone, probably they will give us feedback. So realistically, I think only by the end of the year, most probably we will have a good thing, hopefully, in terms of the prompting.
Thank you very much.
Yeah. And again, if anyone wants to implement it, please talk to me.
Okay, there was another question for now. We have a couple of minutes. Last question. Do you plan to have a cheap educational license?
Yeah, so absolutely. So yes, as you can imagine, this is really, really expensive if someone wants to use it. So the idea is next that we will roll out the standalone for smaller studios, but that will still be a bit expensive. What I want to do simultaneously, as soon as we have the import and the export button, just to start creating this community of, can be researchers, can be gamers, whoever that would be willing to use the tool and provide us feedback. So that will have no cost at all. So it has, because it has no commercial usage. So
That would be great.
Yeah.
Otherwise, you are showing something today. Okay.
Yeah.
You will never use that.
no, you will, yeah. And as I said, I'm a researcher, right? So I would be, it's the whole philosophy to give back. But I think everyone here in this room, if I could give you these tools to create, new, more innovative technology on top of what we have, because you think properly, right? So yeah, as soon as I have the info button, that's the thing. We get info button.
Thank you very much.
Thank you.
Okay. Next presentation can start preparing.
It was a short paper, so it's there. So she's connected and asked if she wanted to go back to it, and otherwise I will yeah. Great, 9 minutes and then
okay. Okay, we will now go with our session number 4, which is the last one of our presentation, regarding smart cities, IoT, and human-computer interaction. Session chairs are Ana Cristina Lopez and Bruno Miguel Rodriguez. I will leave the floor to them. We'll check on the presenters.
Thank you very much. Welcome everybody to our session number 4. It's a great pleasure to review a wonderful set of 5 papers to be presented. The first one will be presented by video because the others unfortunately are not able to be here. So I'd like a quick check to see if the 4 authors of the following papers are here. Egon Orion, thank you. Nicholas Hoffman, it's here. Perfect, thank you. Min Blue is the author of paper number 9, Node-bearing vector system here. Okay, is it? And it will be online. Thank you for checking. And the last author is Júlio Castro Lopes. Thank you, Júlio. So I think we can begin. Unfortunately, the video that we received for the first paper is slightly over the time limit that we have established, so we will try to crop the video in the middle and step up to the conclusions phase. Hopefully we will not lose the topic of the presentation. So if you could start now with the video for paper 22, please. Sorry?
They're asking if she wants to present
Online?
online.
Okay,
Maybe
perfect.
she's
Oh, yeah. So the author is online with us, and she can maybe do the presentation and try to accommodate the time that we have available. So it will be around 9 minutes for the presentation, to leave 1 minute for the discussion, please. So we are going to present a video for the first paper, which is entitled "A Unified L-Power Gateway and IEEE 802.15.4G Mode for Enhancing Indian Smart City Networks."
Hello everyone, I am Dr. Sita Devi Bharatula, Faculty of Department of Electronics and Communication Engineering, Avalta ICIR2024, Chennai. I am here at IEEE International Conference on Intelligent Reality, ICIR2024, to present the paper ID22, titled A Unified LPWAN Gateway and IEEE 802.15.4G Mode for Enhancing Indian Smart City Networks, co-authored with Ms. Divya, Ms. Kumulali, scientists from CDAC Chennai, and Gopal Babu, and myself, Dr. Sita Devi Bharatula from Amrita ICIR2024, Chennai, India. The presentation goes like this. Introducing smart city networks. In India, urbanization is growing at a very fast pace, and which immediately leads to increased demand for efficient infrastructure. And the present smart city networks that are present, they are facing two challenges. One is scalability and the other one interoperability issues. Scalability makes it difficult for the networks to grow as the cities are growing, and the interoperability issues hinder the seamless communication between different types of devices, which are very common in IoT type of networks that are present in the smart city networks. And the research hypothesis is like this. Can a unified LPWAN gateway improve network efficiency in smart cities? So, the unified LPWAN gateway definitely improves the connectivity issue, and therefore that means that it enhances the connectivity, and it better manages the data that is coming from different devices, and so the data management will be better. And the hypothesis here aims to assess whether a unified system reduces operational costs and resource usage. That is, whether it improves the network efficiency. So towards the end of this presentation, definitely we all will come to agree that network efficiency will be achieved with the unified LPWAN gateway. So, understanding LPWAN technology, the LPWAN stands for Low Power Wide Area Network, which is optimized for long range communication, and it is very power efficient. It draws very low energy, which makes it suitable for battery operated devices. And because it is optimized for long range communication, it covers extensive areas compared with other networks, and it is best suitable for IoT applications and smart city integration. Also, the LPWAN facilitates efficient data transmission, which is vital for smart city infrastructure and services. And coming to IEEE 802.15.4G 802.4G standard, it is designed specifically for low-rate wireless personal area networks, that is LRW bands, facilitating efficient data transmission, and they are low-rate communication, that is communication that is happening using 802.15.4G standard. It is very optimized for low-rate communication. It makes it suitable for various smart city applications like smart metering and environmental monitoring. And the communication that happens through 802.15.4G standard is very robust and reliable. Therefore, it is very essential for maintaining the integrity of data in smart city environments. And it is very suitable for smart city applications such as traffic management and public safety systems and smart health services, which enhances urban living. Comparison of IEEE 802.15.4G or other LPWAN technologies is given here in a table. Certain metrics are considered, and the other technologies that are under consideration with LPWAN are Sigfox, LoRa, and NB-IoT. And when coming to some of the metrics, when frequency is considered, Sigfox and LoRa, they operate in unlicensed ISM band. Sigfox uses 868 or 915 MHz, whereas LoRa uses 433 and 866 and 915 MHz. NB-IoT operates in licensed cellular, and it takes the frequencies 700, 800 and 900 MHz, whereas the 802.15.4G operates in unlicensed ISM band, and it takes the frequencies 868 or 900 MHz. As far as range is considered, Sigfox gives us a range of 10 to 50 kilometers, LoRa gives us a range of 5 to 30 kilometers, NB-IoT gives a range of 1 to 10 kilometers, whereas 802.15.4G achieves a range of 5 to 10 kilometers. And data rate is considered, Sigfox gives a data rate of 100 to 600 bits per second, and LoRa gives us 5 to 30 kilometers, 0.3 to 50 kbps. NB-IoT gives 20 to 250 kbps, whereas 802.15.4G gives 50 to 300 kbps. When power consumption is considered, Sigfox is the power consumed by Sigfox is very ultra low. LoRa consumes very low power. NB-IoT consumes low to moderate power, and 802.15.4G consumes moderate power. When payload size is considered, Sigfox is able to achieve 12 bytes uplink payload, and the payload size that is achieved with LoRa is 51 to 243 bytes, and NB-IoT is able to manage a payload of up to 1600 bytes, whereas 802.15.4G it supports larger payloads than all these technologies. When scalability is considered, Sigfox can be scaled to millions of devices, and NB-IoT also can be scaled to millions of devices, and LoRa, the scalability is high, and in the case of 802.15.4G, the scalability is very high. And as far as security is concerned, Sigfox sticks with the encryption standard AES-128, and LoRa also sticks to the same standard. NB-IoT security is SIM-based and cellular grade. And when security is concerned with 802.15.4G, it is AES-128 encryption standard, and it is network level security. As far as latency is considered, it is very high for Sigfox, and it is moderate for LoRa, and it is very low for NB-IoT, and 802.15.4G, the latency is very low to moderate. And bidirectional communication is limited in case of Sigfox, whereas bidirectional communication can happen with LoRa, NB-IoT, and 802.15.4G also. And as far as cost is considered, Sigfox is low device cost. Device cost is very low, and similarly for LoRa also device cost is low, whereas infrastructure cost is moderate. And NB-IoT is considered, it is the cost is higher for device as well as data plans are also having a higher cost. And 802.15.4G, it has its cost is very moderate. Whereas mobility is considered, Sigfox and Sigfox is having limited mobility, and LoRa supports mobile devices. NB-IoT supports full mobility, and 802.15.4G is having limited mobility. Advantages of 802.15.4G over LoRa. 802.15.4G is open standard. It is ensuring vendor neutrality, and it is having broader interoperability, whereas LoRa is proprietary to Semtech. Data rates are considered. 802.15.4G supports up to 1 Mbps data rate, suitable for applications requiring higher throughput, compared to LoRa's typical maximum 500 kbps data rate. And topology is considered. It is very flexible in case of IEEE 802.15.4G. It supports both the, it has both the star and mesh network topologies, enhancing reliability in challenging environments to have the maximum benefit. And the smart city networks, then they have this, and then the citizen satisfaction will be very high. And of course, cost savings, unified LPWAN gateway, and IEEE 802.15.4G mode. They are as follows: unified LPWAN gateways. These gateways integrate various network technologies, facilitating seamless transmission of data. 802.15.4G modes. They are low-power wireless devices that are designed to enhance data transmission efficiency in urban environment. Improved connectivity, a combination of LPWAN and modes enhances network coverage and reliability for smart city application. And data management, advanced data management systems, they enable better analysis and utilization of city-based data for better decision making. And urban development can become more sustainable with unified LPWAN gateway and 802.15.4G mode.
So, thank you, sorry for not being able to show the entire video, but we can get a general idea of your proposal of the paper. If there are any questions from the audience, I think we have one of the authors online that could answer some questions. If no, I will try to pose a question to the author. In terms of the available infrastructure, of course, we are aware that India has a scale geographically which is almost incomprehensible for us. In terms of the availability of this infrastructure, how does this standard compare with the other standards that you have proposed or analyzed in the paper like LoRa? I don't know if you were able to understand the question. Yes, now we can hear you.
Could you please repeat the question?
Yeah, I was wondering in terms of the availability of the infrastructure for the implementation of all of the algorithms and the standards, communication standards that you mentioned in the paper, notably the comparison with LoRa. What is the current status, particularly in India, but also around the world, of course?
Yeah, actually, CDAC and Amrita is jointly collaborated with each other, and some student projects are going on under CDAC scientists mentorship. This is a practical work done by the student, and I'm his faculty mentor at the institution. And it is directly done under the supervision of CDAC people. So, CDAC is a government laboratory under the Ministry of Electronics and Information Technology, Government of India. So, they are having funds to carry out all these projects, and using the student project, they have identified the various technologies and how to go about. And so definitely they are in a good position to implement these things.
Okay, thank you. Sorry also for the difficulties in communication. Thank you very much for your answer. I think we now can move on to the second paper in this session. Thank you.
Thank you. So let's move on for the second presentation, entitled Design of a Physiologically Based Feedback Loop Using Biosensors for Interactive Extended Reality and Spatial Environments. It will be presented by Egan O'Reilly. I'm not sure if I pronounced your name correctly. Close. Sorry.
I like to add a few extra letters to make things more difficult.
Okay, thank you.
I'm very sorry for this delay.
So my name is Owen O'Reilly. I'm very close. So I wanted to speak about the design phase of our project, which is the design of a physiologically based feedback loop using biosensors for an interactive XR environment. So this is a multi-site project where we did this as UCC in collaboration with UCD NT site in the UK. It was also partially funded by an EU body under the project Scaling for Rehab, which looks at scaling up digital health interventions. So to start the project, we asked ourselves a question, and that was, does an individualized feedback loop enhance user interaction and sense of presence? So to answer that question, we designed a physiological-based feedback loop using biosensors that could be integrated into a VR setting. So we developed a prototype system, and from the early indications and testing that we've done so far, it seems to be a viable solution. So the applications where we would see this working is in digital health, and what makes it a successful VR therapeutic intervention is that it's dynamic and personalized to a patient. So that will then improve their outcomes by ensuring adherence to their treatments. So instances where we would see this as beneficial is instances of long COVID, persistent pain, and other chronic fatigue conditions. So in order to determine the physiological response, we were looking at stress as the response. So there was 4 areas that we wanted to explore, and that was the brainwaves, heart rate, galvanic skin resistance or response, and the temperature. So for the brainwaves, we were looking at the alpha and beta waves specifically. For the heart rate, we were looking at the intermediate intervals, and the rest speak for themselves. So in order to look at these, what was it that we wanted? So we wanted to get the full biosignal range of these signals in particular, and then establish a baseline for a user in a neutral condition. Once we had the baseline, we could then determine any variations based on stressor stimuli and stressor cues. So with this, we had our 6 components, and then from the baseline, we could determine if there was an increase or decrease based on that baseline. So what we would be looking for is increases in the theta wave, decreases in the alpha waves and the IBI, and also increases in GSR temperature. And then that would designate a stress response in the user. So the design and feedback loop. So if we go to the start of our process, the user enters the virtual reality environment, and the biosignal or the biosensors start generating raw data. This data is pre-processed on device, and then it is collected and processed before being aggregated into an ensemble that can be analyzed for the digital signature or for the stress signature. If stress has been identified in the subject, the feedback loop will regulate the stimuli in the virtual environment in order to keep the user in the optimal state. This then starts the cycle again where the user responds to that stimuli and raw data is generated. So the prototype architecture. So we began with one sensor, which was the empathic E4, which gave us our GSR, IBI, and temperature. This then sent the raw data to the ELE client on our computers, which then sent the process data to the headset. Since then, we've added a second sensor for the EEG data, which was the manipulated by NeuroSky. That also sent the raw data to a ThinkGear connector on our computer, which then processed the data and sent that back to the headset to be fed into our feedback. So the empathic E4, as you see here, has 3 sensors: the EDA electrodes, the PPG, and the temperature gauge. So these are just some normalized data to kind of represent what we would be expecting. So the IBI is read at 64 Hertz, which is a nice rate. The GSR and the temperature are at 4 Hertz each. So the aim of the game is that we have a responsive system. Next was the mic line. So the theta alpha and alpha alphas get normalized down, but just to see here, they work at a much higher sampling rate of 512 Hertz. So a constant stream of data, which is very important, that can be fed into our feedback. So I should clarify that the VR environment that we're creating is a plank walk experience. We thought that would be appropriate to induce a little bit of stress in the user. So we wanted to identify components that we could adapt to the scene. So the first one that we used as our prototype to see if this was viable was to create audible synthesized heartbeat that's directly linked with the IBI to the user. So that was successful, which prompted us to move forward into other components like visible or visibility manipulation. So if the user is becoming overly stressed with the height issue, we can reduce their field of vision, so that will try to mitigate against that. Next was we had just a mood bound user interface as sort of a novel approach where the user could, like those mood rings you'd see when you were younger, could see what state of or physiological response they were in. Next was the creeping of the plank. So if somebody is strange and has no fear of walking over a plank at a very tall height, we can cause the plank to creep and move in order to get that stress response. Or if they're becoming overly stressed, the feedback loop will steady it and they will no longer hear any creeping. So findings from our prototype was that it's very, very important to have a reliable baseline for each individual user. So that means that if the user went in and created their baseline while stressed, that could interfere with the feedback loop. Next was good sensor contact. So in order to ensure no noise being introduced into the signal data, good sensor contact must be kept. Ergonomics, so we want to make sure that the user is present and feels immersed in the environment. So wired versus wireless experiences, we don't want the user to get tangled up in cables and have to readjust themselves. And VR responsiveness, so like I said, a responsive environment is key here, that once the data is received, it is acted upon in our feedback loop. So going forward, we're proposing that we go into a pilot stage of our feedback loop integration and evaluate its integration through quality questionnaires and comparing that with our measured physiological stress signal. So our discussion points is just to identify the limitations of the prototype. So we began our project with one sensor and one adaptable component. So since then we have moved forward into multiple sensors and multiple components, so we're trying to address that limitation. Next was that this experience creates an individualized and personal experience, because no two users will have the same experience at once, because their baselines are different, the way they react to situations are different, and therefore our feedback loop will adjust appropriately. Next, that also creates a strong sense of presence, that the user feels they are having an effect on their environment and they feel that they are immersed. So with multiple biosensors being included, that raises another question, which is of data fusion. We need to ensure the data is being brought in and aligned to ensure an accurate signature of how that user is feeling in that particular moment. So we do this by timestamping the data as it comes in and ensure its alignment. Next steps we look towards is, now that we've identified a pattern for stress, that we can then feed that into an AI or machine learning in order to more efficiently identify stress signatures. So that's me. Any questions?
So we have time for some questions. Anyone? I have, do you have one as well? Okay, so I have one. Which type of biosignals did you feel are more effective? And what are what issues did you have with data fusion? Was the data concerning to the different biosignals synchronized? They were...
Yeah, so I suppose
you synchronize at the timestamping, I understood that.
Yeah, so in terms of the issue we found, data fusion, having the different signals coming in at different sampling rates created the issue of we may get an EEG signal with no heart rate at that moment in time. So it was a case of it would use the previous data and pull that forward to align, so that there would always be a consistent row, but it may not be as accurate as we wish. Higher sampling rates is what we're looking for in uniformity. First question you had?
Which biosignal did you feel was more effective in terms of wearability, in terms of accuracy? Can you give us some lessons learned at least?
One lesson learned that we found, that I found particularly interesting itself, was temperature. So the data we learned was that temperature in a user would rise when they're in a stressful situation, whereas in some instances, when stress occurred, their temperature decreased on the wrist. Now, reading into that, we found that if your temperature rises in your hand, it might decrease in your upper arm. And having the sensor here may have caused that variation. So it was an interesting insight that we hadn't expected at the time. But still looking into that.
Okay, thank you. More questions?
Thank you very much. I'm the speaker again. Now we move on to the next presentation, which is by Nicholas Hoffman, mechanical
for preparing. The title of the paper is Data-Driven Control of a Wind Pollution and an Excavator Within Web.
Thank you. Thank you, everybody. Thank you for the opportunity to present our work. So I will present what I did with my colleagues, Max Cohen, Muriel, Marius Preda, and Titus Daria, and of course myself, Nicolas Cohen. It's a work that we did in Paris, in the lab in collaboration with our partners, Arcus Robotics, that works towards automating the machines that do earthworks. A few words of context. So this is the office of our partners, you can see on the left. And right next to the window, you have the machine, which is a 25-ton excavators from Caterpillar, and we have robotized the machine, control of it, and what we want to do with the company is to make this machine autonomous, and more specifically, move the arm of the machine, that you can see on the right, autonomously to dig a trench in the ground. We use the machine of our partner, which is great, because it's not a proof of concept that we can make in a lab. It's something that we can directly deploy in the industry, at least with this kind of machine. But it's also challenging because we have limited sensors. For example, here we only have the 3 angles, alpha, beta, and gamma, and we cannot add new sensors that it will prevent deployment of the solution, or replace sensors for more precise ones at the same result. So what do we do? What I present here is our work towards a teleoperation tool that can help the supervisor when the machine ultimately stops for safety reasons. So we are working on a VR teleoperation system that will allow the supervisor to send commands, in our case speed, to the robot that will process the command and do what we want to do, and the robot will answer with its position, velocity, and what it sees around it. So in this case, the virtual excavator that we see in the VR, the digital twin of the real one, and we can teleoperate the machine remote. What we used before this work was a very simple controller inside the machine, inside the robot, it's a PID, and it was not sufficient. The problem we're facing is that when you are controlling this kind of machine, physically inside, you get a lot of feedback from the sound, from the vibrations, even sometimes from the force feedback of the joystick that we don't have with our system in VR. So we need to help the supervisor. So what we want to do is to improve on this basic control. So we start by identifying the dynamics of the machine. So just a few notations, the state of this covered arm that we define as the 3 angular positions, alpha, beta, gamma, and the 3 velocities. And when we want to move the arm, we have to move the joysticks with our hands. And so we define the input commands as the 3 signals that we send to the joysticks for the boomstick and boomstick and magnet, sorry. We control by wire the joysticks to take control of the machine. And the first step in identification was to create a simulator of the machine because we cannot access it. And when we want, when we're training our controllers, we cannot make it dangerous trajectories. So we want to simulate trajectories of a sequence of states that are determined from where we start. To do that, we collect a dataset. So I won't go into the details, but we collect about 1 million transitions of state, actions, and next states to train our network. We do that by oscillating out the phase of the articulations. And we choose network architectures, we can see here. You might start with an MLP, where you concatenate the state and action as an input to the network, and you train it to give you the next state as an output. But this approach does not consider the number of features. So you can go into stack LSTMs, but you would stack several times step as an input and still give you the next state as an output. Or you could go into recurrent networks, for example LSTMs, that will pass the number of features 2 times. What we suggest is to combine both approaches, where you stack the inputs and you pass the parameters. Once you have your network, you have a lot of hyperparameters that you have to train and optimize. So this is what we do, and we get this video that's moving, it's fine. So what you will see here is the four different architectures that are trying to follow the ground truth around. So I can mimic with my hand. And you will see that the two blue architectures are following quite closely the green, which are the LSTM networks. But the two red architecture KMLPs will accumulate errors early in the trajectory and go all the way up and be stuck there because of their poor prediction capabilities. We can measure the quality of all of these models on the left, and we can see that the stack LSTM dominate the others. So once we have our model that we consider to be good enough, we move towards control. So what we want to do is to reach the speed desired by the supervisor. So we define this as the three velocities, three angles desired by the VR supervisor. And we need to compute the joystick signals too as a function of what we want and what we have. And here we experiment with three families of controllers that use the model in different ways. So in the left, we start with not using the model, with a PID, or using an inverse model to linearize the system to make the PID work better. With a lookup table or with an inverse model of the system. In the middle, we experiment with models, with algorithms that will use the model online when you need to compute your input, so MPC algorithms, MPC methods, that will simulate different control trajectories in a short window of time, for example, one second, and pick the best one. The issue here is that we have a neural network model, so our model is quite slow, and we cannot simulate a lot of input trajectories. So we're trying to accelerate this process by imposing constraints on the sequence of inputs. So for example, we can impose a constant input through the whole window, or follow spline with less parameters than there are text tests. And finally, on the right, we are experimenting with offline training using the model, this model, in our case with a deep reinforcement learning model, so that when we need to control our system, we don't need to use inference or slow model anymore. We can use the agents directly without having the problems of performance. I think I will spare you the details of how we implement our controllers, but what I want to show you, what I would like to show you, are the simulations. So here we are training in simulations offline. This would be a deep reinforcement learning controller that is trying to follow a sequence of points that we sample randomly, and some of them are sampled close together, some of them are sampled far away from each other. And in this way, we are training our deep reinforcement learning controller to follow trajectories that will go fast or slow. We also use this setting to optimize all the hyperparameters of the other methods. So we had 7 methods. We have the 3 PIDs, the 3 PCs, and the deep reinforcement learning. And once everybody is trained, we can evaluate the performances on a trajectory we actually care about. So in our case, for example, following a straight line, it's surprisingly difficult with an excavator to follow the straight line because you have to dynamically adjust all the articulations to follow exactly what you want, as opposed to making circle arcs over and over. It's quite difficult, and we observe that the tracking performance degrades as we speed up the trajectory, which makes sense. And so we can, and we do evaluate all of our 7 controllers in this specific trajectory with different speed, and we plot their tracking error as a function of the speed. So in the horizontal axis, it's the speed. We want to be as fast as possible, so towards the right. And in the vertical axis, this is the tracking error. We want to be as precise as possible, so at the bottom. And the perfect controller will be at the bottom. So here we can see all the controllers sorted by color, that provide a trade-off between precision and speed. And we can see, for example, in green, this is our deep reinforcement learning controller, and it dominates the others, starting at a speed of maybe half a meter per second. The red controllers correspond to the PIDs, and we can see that with the local table, we were able to vastly improve the performances even at very low speed to dominate the others. And the blue ones correspond to the NPCs, and you can see the two light blues correspond to two ways to speed up the NPCs, and once again, that intermediate controller is the dominant. This is for the line. We can do exactly the same thing for another trajectory that is very important for us, which is the scoop. The scoop consists in loading the bucket, so we start by extending the arm, and then digging into the ground and filling up the bucket. And we observe roughly the same behavior. So for our future works, we're working to deploy and study the impacts of our better controllers with the supervisor, not only on performance, but also on the cognitive load. Because the supervisor himself is a controller that will adapt to what we give to him. And so it's not only about being faster, it's also about the experience that he has and to be smoother and less, to pay less attention to this. And on the other hand, we're studying the robustness and the reality gap of our control, because so far it's only on simulations, and ways to improve the safety in case, for example, a sensor breaks down. So thank you for your attention.
Wonderful presentation, also for keeping the right time for the presentation. Now we have some time left for some questions. No questions? Well, I have these two. First of all, do you have an idea if the competition complexity that you have now in your system will be sufficiently low to be implemented in the real excavation? That's the first one.
Yes. So about the computation complexity, we already have a system in place with ideas, so it's basically zero complexity. And we measured the speed for all of our controllers, and only the NPCs impose us to slow down. So we use by default a 20 Hz control loop, and for the NPCs we have to go down to 5, because in training we discovered that it is the optimal way to get the best performance. But for the other ones we can go way higher and just make it 90%.
The second question is, are you planning to take into account disturbances that may come from obstacles in the terrain, like rocks and other?
Yes, thank you very much. This is a very critical step in our work. We're trying to model the interaction with the ground from data, and this is very difficult because the future of the trajectory does not only depend on the mass, it also depends on the shape of the ground and the properties of the ground that we don't know. And so we are starting to experiment with stochastic networks that provide us an output, not the next state, but a distribution of states, so for example, like a Gaussian distribution, and we try to match that with recordings, with interaction with the ground, but this is very early development. Thank you very much.
Thank you very much, Nicola. Thanks for being here.
So, we are going to move on for the next presentation. I suppose it will be a video as well. It will be presented by Min Sok Du, also troubles with the name, I'm sorry. The paper is entitled Node-Bearing Vector System, Advancing 3D, 2D Vector Storage and Mesh Design.
I appreciate to ICIR2024 for accepting my virtual presentation. I will introduce my full paper about node-bearing vector system for advancing 2D 3D vector storage for 3D mesh design. Node-bearing vector system design for integrating the polygon and NURBS modeling for 2 major courses. First one is easy to edit and more accurate modeling, and second one is improving memory efficiency. The early proof of concept proceed with Python after I turned to C++ based OpenGL for more accurate proof of concept as an industrial pipeline. Polygon modeling is widely used in graphics, robotics, and view development. NURBS offer high precision but are computationally intensive, but product design, architectural design, those things that are more accurate require designer using the NURBS. Challenging as a large polygon database reduces performance and efficiencies and needs for minimal texture distortion. There is several different technologies for subdivision and normal maps trying to mapping the more higher accurate 3D modeling with the lower data, but it still has a distortion as a texture. Proposed solution for the direct vector system combines the polygon modeling and NURBS, and it offers a real-time editing with near NURBS accuracy. Normalized fixed point are designed for faster calculation because the vector system requires a large data, and node-bearing vectors are a key concept of this paper. Node vectors define the location of the vector, bearing vector define the rotation of vector, and force of vector. Vector depths are designed for calculating multiple bearing vector for creating the more accurate curve. Segments, linear segments are designed for combining the B-line and B-spline line, and surface segments designed for index level. Calculation and visualizations. Total influence are designed for calculate the multiple directional and force influence. Final node positions are designed for calculating endpoint of the line. Linear segments. Bezier curves are designed for create accurate curves integrated for the current industrial pipeline. Curvature analysis are using for multiple bearing vectors, and starting point of node vectors says bearing vectors, and endpoint of the node vectors of bearing vectors, because we need to calculate both the bearing vectors, directional and forces, because it has a final destinations. For the early proof of concept, I used Python, demonstrate the integration of polygonal lines and these lines with the real-time recalculation of chip and the OpenGL environments. Stress tester proceed with the Python code with the TensorFlow metal library. Memory using scale from the 0.53 gigabyte to the 5.50 gigabytes. Computational time increased from 0.13 seconds to the 5.48 second per instance. Render tests are really rough from the polygon status on the Python. So here's the two major images for result of this paper. First image explains how this node-bearing vector system integrates the polygon modeling and B-spline line. There is three different types of the linear segments. First one is just node vector, node vector. Node vector with bearing vector, and node vector with no bearing vector. And third one is node vector with bearing vectors and node vector with bearing vectors. So one is just B-spline, B-line, and two different types of B-spline line. B-lines are integrated with polygon modeling because polygon modeling vertex does not have curvature functions, and B-spline line type type 1, node vector with bearing vector and node vector with no bearing vectors are simulating how it could integrate the polygon modeling vertex and the nerves vertex. Nerves vertex has a curvature function, so it has a bearing vectors with the force component and bearing vectors without bearing vectors. It's simulating the polygon modeling vertex. So while integrating those two things, it's the curvature functions are working as a calculating just one side of the bearing vector. And B-spline line type 3, the node vector with bearing vectors, two things are calculating both the simulations on the force and directions on the bearing vectors. Stress tests are proceed with the 1 million node vectors to 10 million node vectors. Usually 1 million is that vertex are utilized for the polygon modeling, which means probably in the node bearing vector system, 1 million node vectors could not be utilized. It's for stress test for forces. And second image explains how I try to do a stress test. I made 1 million node vectors to growing up to 10 million node vectors and create a B-spline line between the two different node vectors. So this is the second proof of concept with the OpenGL with the C++ base script. I simulated in the creating the curves by using the very vigor system with the live encryption from the OpenGL. So this is the actual test to explaining how it could integrate with the actual industrial pipeline. Honestly, this is one of the horrible results from this study. This is a really early test of the render test. I sampled the entire vertex using the bearing vector system's linear segments, and connecting those linear segments is the sampling point for creating the polygon. And I use general polygon rendering for creating the render test. Honestly, it seems like it could work, but it referred to we need to improving the actual rendering shader language process by using the GeoSL or HLSL for creating the more accurate rendering system for the node bearing vector system. So here is some key achievement. Strength is scalability for large data set, integration potential with the industrial pipeline, and eliminate needs for retopologies and normal mapping. I think that removing the retopologies process are really important because the bearing vector system using auto calculation for creating the B-spline line and sampling point of vertex. So it means it does not need to do retopologies for calculating the actual shading result. It's our early stage of the study, so like that the comprehensive mesh rendering test as before I showed, and no direct computation ability with the industrial pipeline yet because I did not simulate the actual file converting test between the node bearing vector system and standard industrial format like OBJ or FBX. Feature directions, optimizing the normalized fixed point and integrating the pipeline tools between such as like blenders or Unity and Unreal. Before going on the conclusion, I different questions after arising this study. First one is, do we need to create the baseline line as a creating the actual hash data? I don't think so, and I think there has a more smart way to calculating the actual hash data by using a very vector system. First question is arising the sampling between the calculating the control point of the baseline line. In this study, I using the calculating the baseline line by the calculating the calculate point and note on the force vector, and it's make an additional step for make it sample data. But by using the node-bearing vector, because node-bearing vector is actually simulating the physics, I think the quantum sampling might be worked for create the more accurate sampling data and more faster. And second question is Nth-dimensional topology system, because it's this node-bearing vector system using multiple vectors. Vector including the vectors, and it has a rotation matrix. It's creating the multiple dimensional vectors data in the node-bearing vector system. And the one of the hard thing is create the index to indicating which node vector and which bearing vectors force integrate as a one vertex. And I think maintaining the Nth-dimensional topology system as a relationship between those different type of data might be more effective to indicate those different elements of vectors more effectively. And after going to conclusions, this study developed the graph of the node-bearing vector system, how to integrate the baseline line and B line between polygon modeling and NURBS modeling, and real-time interaction between moving the node vector with their vectors and creating the live interactions curves with the OpenGL. Next step is extend to the more larger industrial system like Vulcans, Vertex, Metal, and actual modeling system such as Blender, and Unity, Unreal Engine. Those kinds of things will be next things for make node-bearing vector system actually in the industrial pipeline.
I suppose the presenter is online. I don't know. We have time for a short question. Hello?
Hi, can you hear me?
Yes, we can hear you. Hello, how are you? So, we have time for a short question, please. Anyone? I have a short question. You said that you have some limitations concerning the compatibility with industrial pipelines. What are your expectations concerning your future work, and how are you expecting to deal with this limitation? What are your expectations?
Yesterday I talked with the Blender team, and nowadays I'm planning to integrate with the bearing vector system with the Blender. And the biggest problem with the combining current industrial system, it seems to be making new type of objects, because it's basically a totally new vector system, so it seems to need to develop new object system to integrate with general polygon modeling tools. I think that could be the biggest problem, and it leads to a lot of data conversion tests and a lot of more ambiguous development tests for combining different industrial modeling tools. Yes.
Thank you so much, Mr. Blue. Let's move on.
So now, for the final presentation of the session, I call Júlio Castro Lopes, representing the paper entitled Partial Occlusion in Facial Expression Recognition, Systematic Literature Review. Júlio, the floor is yours.
So, hello everyone. I know that you are all thinking on coffee break. I'll just take you 10 minutes, don't worry. So, basically I'm here to show a systematic literature review that we did on partial occlusion in facial expression recognition. So to begin, as you all know, facial expressions are the most common way to externalize emotions. They are one of the most important means of communication between interpersonal relationships, and through facial expression recognition, we can provide clues in understanding and inferring the hidden emotional state of individuals. Also, as you may notice, facial expressions are executed automatically without you even realizing that you are executing them. The automatic identification of this type of expressions introduces several benefits in several scenarios. So, regarding facial expression recognition, so basically facial expression recognition is a subfield of computer vision that focuses on analyzing facial features to determine occlusions. Basically, we employ algorithms to interpret the visual data, enabling the machines to understand the human emotions, classifying them in different categories. We have distinct applications of this type of algorithms, for instance, in healthcare for patient monitoring, in education for enhancing learning experiences, customer services to gauge consumer reactions, and also in serious games to optimize user engagement through emotional recognition. So, regarding the challenges of partial occlusion in facial expression recognition, in the bottom you can see some of the regular occlusions that we can deal in this type of problems. So, these are the challenges of one of the challenges of facial expression recognition. We can have several of them. Also, regarding the partial occlusion, you can see that it is a challenge because there are certain parts of the face that are hidden, so the algorithms may struggle a bit in recognizing the expressions related with the face with no occlusion at all. Most of the common cases you can see in the bottom, for example, a mask. Also in a serious game, that is the application that we most deal with. We have the occlusion of the VR goggles, and this is a challenge for us. What are the challenges for the partial occlusions? It is the inaccurate feature localization because we don't have all the features displayed, and the misinterpretation of emotional states because we can be confounded with some different emotions. So, regarding the systematic literature review itself, basically we aim to do this type of review, and the main focus of this paper was to find what is the type of occlusion that impacts the most on facial expression recognition. So we used a simple query just with facial expression analysis and recognition, and also partial occlusion. We included several quality assessment checklists, and finally it resulted in a total of 13 papers just. So to extract the data from the papers, we used the Parsifal tool. We used 9 different data extraction queries. The first one was to extract the data sets, the second one to extract the methods to perform the occlusion, then how the different types of occlusions impact the recognition of the facial expressions, what are the challenges found when dealing with the partial occluded faces. Also, if we have in the papers, the paper suggests some future areas of improvement to address these kind of problems. Also, if the system was developed to classify the images in real time. What are the machine learning models used to classify the expressions? What kind of occlusions are addressed? And also how many emotions are contained in the data set. So finally, to respond to our research questions, we developed 4. That is which type of occlusion most penalizes facial expression recognition. That is the most important one. We also checked what algorithms are used to simulate the partial occlusion, what is the most popular data set, and also what are the main open lines of research and issues in this domain to continue with further research. So for the first one, we concluded that it's not clear at all what kind of occlusion impacts the most on facial expression recognition. Because there are some studies that say that basically the lower part impacts the most, and some of the studies that the upper part impacts the most. And there are also some studies that perform different type of occlusions, but the most popular ones are the lower and the upper part. Also, what algorithms are used to simulate the partial occlusion? We concluded that basically many investigators in this field are in favor of using Gabor filters for both the feature extraction and also for the facial expression classification. This method has proved effective across various occlusion scenarios, including lower, upper, and other types of occlusions. This may be due to the adaptability of Gabor filters in any occlusion strengthens which strengthens their position in facial expression recognition. One of the things that you'll see here in the further research question, it is the most popular data set. Basically, the most popular data set is the normal data set, as all the data sets that we found, because basically there are no data sets with the occlusions performed. So we need to perform some kind of algorithm to simulate the occlusions. And most of the algorithms used, for instance, black patches to simulate the occlusion. Also, what are the main open lines of research or issues in this domain? So we concluded that we need to perform a better exploration of how occlusions influences the facial expression regions. Also, we need to perform a better examination on the significance of specific facial features, and we need to establish, for example, development of a data set with the occlusions in real life, because it can be different, the impact of these occlusions in real world scenarios when comparing to controlled ones when we have black patches. Just to finalize this part, what are the most relevant papers? So it's just an overview of the papers. Basically, in this paper, the authors used a non-negative matrix factorization. Here you can see a paper that uses just sparse representations with LDPs. Then a paper that uses Gabor filters. As I said, that is the most popular algorithm. Also Gabor filters one more time. And here a combination of Gabor filters with local binary patterns, the LBPs. So the conclusions of this paper was that we have 3 main types of occlusions, that is the upper, lowers, and others. And we concluded that the most popular method was the Gabor filters to perform the feature extraction and also the classification. And as I said before, the partial occlusion simulation, most of the studies use black patches to simulate the occlusions. Basically, what we can conclude is that we need to create new techniques to create the occlusions and represent real life conditions to perform a better evaluation of this. And basically, finalizing, just a quick spoiler, we did a research paper that was already published, into which we concluded that the mouth region is more, it impacts more on the facial expression recognition. And that's it. I hope I didn't take too much time.
Thank you very much. I'm sure we are in fact considering a coffee break, but we have time for a few questions. The audience first. Any question? Well, I have one. Refreshingly and surprisingly, the result was the best result for you is based on the conventional method, so which is something very traditional, our filters. From the papers that you showed, what were the publication years, and how do you have an idea of this model-based method, how the filters-based method compared with the deep learning solution?
All the papers are basically, most of them are from 2010 to 2015, just. So the most recently there are not many papers that deal with this, at least that we found in our work, of course.
Okay, thank you very much. That will explain the reason. Any more questions?
Yes, I have one. You said that the mouth is the most impactful?
Yeah, at least from our study, yeah. We performed different type of occlusions, and we concluded that the mouth region was the region that impacted the most. We are conducting further studies to maybe introduce and evaluate each of the features really are the most important ones, but we concluded that with the lower occlusions we have decreased the accuracy in classifying the facial expressions.
For every emotion or for specific ones?
With 7 different emotions, yeah.
But for all the 7 emotions?
Yeah, for all, yeah. Actually, yeah.
Thank you.
Okay.
Thank you everyone. This was the last of our session. Now there is a blended coffee break with poster and demo session, so you can move in the usual location of the coffee break, but we will have entertainment this time. Thank you again.
Before leaving, you have to vote. So this is the last dinosaur that we are going to show to you. It's a QR code for the best presentation that we are going to consider, okay?
I was wondering that should not
Answer it. Your computer is this.
Yeah, so it's just on a board first of all. Yeah, that's what I'm thinking. So we take an average, like what I was thinking was we take the average and also take the standard deviation. First session there's like first session there's like there's these ones where these are trash. Still. Yeah. So yeah, it wouldn't be fair for the sessions with fewer votes. How much time until Mas ok, ou seja, isso também está bem. É que tem o foro, o homem lá e depois tudo aqui, está bem. Bem, eu consigo. Agora estou aqui no foro, mas como é ético, vai ter as duas contas para a outra. Já está tudo? Sim, as pessoas já se só temos 4 respostas e 10 só temos 4. I also prefer not to work with yeah, okay.
Precisamos de uma mesa lá em cima. Uma mesita pequenita só para meter um computador para um posto. O pessoal está.
Vai ter mais tipo 2 ou 3 minutos, mas visto não há mais respostas, está
Quando é tipo.
Passar.
Ok.
Agora coisas de conferência, preciso. Se o José quiser ficar aí,
Mas aí eu não consigo. Mas eu já sei que eu
You want to eat something?
Eat something? It's eating time.
Yeah, no. You can come.
You're full.
yeah,
Or maybe.
Yo.
I have the poster session. So you see, battery bank, headquarters? Power bank. Power bank. So you guys keep in touch with me. I will give you guys if you work on the release stuff. As I mentioned, we have a student, student or senior or one. Next year, I will be sharing that meeting. Okay. As long as you guys contribute, either do something here locally, I can. Each award is $1,000.
No way. Okay, so André, vais-te manter aqui? Vais estar aqui. Liga-me antes de saís que eu tenho que fechar a sala, está bem? Está bem, então. Oh, you have it already?
Yeah, I have it already. Okay.
Just put it in.
And then, I go to the poster session. You guys, first break to start.
Okay, sure. Absolutely. You too.
Is it fun or?
I'm not sure.
Okay, yours.
Yeah, better find out. Yeah.
See you later.
See you. See you.
I don't care.
Oh, that's it. No, it's not me. No, probably. Oh, and me. I hope they have that.
Hi.
People lost their poster?
Houve mais respostas, André?
Houve mais uma.
Então pronto.
Já está. Já tem outra. Gostava. 39, mas estou a ver pelo desjuntor. Ou seja, teve dois desjuntores. Acima do som de estúdio, não? Basicamente, eu fiz som, depois fiz média, desjuntarão, treino
se cria a score amenity, depois dividido pelo júri. Ou seja, assim identificamos os views padrão acima da publicação. Tipo, sai da. Ou seja, eu acho que isso é mais justo do que estar a ver pelo assim, a indicação de quanto mais acima dos outros pés. Mas tem meses que depois de dizer, então, se calhar. Sim, Marisol.
Fazemos só aqui ou só no outro sítio?
Fazemos lá em cima, aqui em cima. Já só subir. Já quer dizer, acho que ainda estou a botar as coisas. E para lá de bicho. Até já. What?
Vou partilhar com ela depois. Então, olá.
Ok. Tá bem. Pronto, vamos lá. Até já.
Okay, it's time to go upstairs for the demos. Try to see how the things are going for awarding the best.
O rola
Não, deixa eu rolar porque ele é no final. Isto ainda tem a cerimónia de beijo.
Então pronto, não precisa levar nada. Não precisamos levar nada, é isso?
Eu diria que não.
So I go home, advice. It was really nice working with you. Let's go on.
Tá bem.
See one day.
Olha, isto é uma projeção top. Estou ali para ver o que é que está a fazer.
Elas assim, o que é que eu?
Acho que vai ser
Pode ir do deck. Este tem comida, este também é.
Oh, but what you're doing?
Mas eu tenho que fazer uma mesas.
You can eat, of course. You wouldn't be shocked. Let me just close the door.
Close the door.
Oh, you want to close the door?
Yeah.
Yeah. What do you need?
No, I have to make a couple of purchases.
Ah.
What is one?
Do it later.
Yes, you need to eat.
What about who is going on?
Leave it, I think, leave it. You can.
Estes são os três que sobram, um é do grupo, o outro é do produção. Sobra um e depois segunda-feira logo se vê tudo. Para começar a terça. Pergunta-lhe a ele o que é que segunda-feira se fazemos uma reunião para ver o que é que ele quer e o que ele quer no jornal.
Yes, at 6. So, you want to stop the YouTube broadcast?
Get everyone in line.
Not perfect.
It won't never be presentations from 10 days earlier, and we said like the whole thing in orchestrate everything. What you did was amazing. And you now?
Instead of going live and you stay forever. Thank you.
Thank you for like I muted the gossip and stuff. It's gonna be on YouTube.
I did you shall you were not checking the answer of whatsoever. Come on. Magic. You should script. Acho que sim, acho que foi no final temos de ter as coisas.
Não, era só porque tinha ali a mochila dentro e era para saber se está aqui.
Está bem, ok.
Bruno, tem que ir lá?
Yeah, it's my laptop.
No?
Yeah, it's my laptop. Yeah, it's inside.
Não, Francisco, obrigado por tudo. Mais uma coisa, Bruno.